Right. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome for today's chemistry lesson. It is a continuation of where Mr. Magara ended last week in chemistry. Our interest is lying in the chemistry of chlorine. You had looked at laboratory preparation of chlorine from about 3 different types. Number 1, from potassium manganate 7. Number 2, from manganese 4 oxide. Number 3, from lead 4 oxide or tri-lead tetraoxide. So we are saying from potassium manganate 7, from manganese 4 oxide, from lead 4 oxide, and tri-lead tetraoxide. This will give us the 4 possible methods or reagents from which chlorine can be prepared. All these 4 possible reagents used, the syllabus stresses that you are so conversant with the preparation from manganese, from potassium manganate 7 and from manganese 4 oxide. Of course, all of them requires concentrated hydrochloric acid as a reagent. What we want to capture is, make sure that you have the content in preparation from potassium manganate 7 and manganese 4 oxide. And I think that one was done and it was over. These 2 are only updates given to you in case of a question in paper 1 that calls for other than what else can be used in the preparation of chlorine in the lab. So these 2 are options catering for a question on chlorine in paper 1. In paper 2, we have a lot of interest in potassium manganate 7 and manganese 4 oxide. As a recap on last week's lesson, it is important that you remember that manganese 4 oxide requires heating, while potassium manganate 7 does not require heating. So here we need to heat. Here the reaction takes place at room temperature. What does it mean? It means that potassium manganate 7 is a very powerful oxidizing agent compared to manganese. It's like somebody who is hungry and who is not hungry. A person who is hungry don't need to instruct such a person to go for food, to go for meals in the dining, because the person is extremely hungry. And remember the saying that a hungry human being is an angry one. So when reactions are supposed to be interface, it means potassium manganate being more powerful, it does not require the process of heating. So those are a few important things that I want to recap on the chemistry of chlorine as discussed with the previous teacher. Diagram of preparation of the gas we looked at and we concluded. I want to mention that later on, immediately the lesson is over, you go and check on the website. I'll have posted the notes for you on preparation of chlorine. Notes will be available on the website for your viewing. So this morning we are supposed to be continuing with the properties of chlorine. Chemical properties. Because the teacher looked at the physical properties of chlorine, among the chemical properties of chlorine, number 1, we shall get interested in the following. 1, the bleaching action of chlorine. Number 2, we shall get interested in its reaction with water. Reaction with water. And I'm reliably informed That is where you ended, and that's what you looked at with the other teacher. Number 3, we shall get interested in the reaction with metals. Its reaction with non-metals. Its reaction with alkalis. And its reaction with hydrocarbons. Those are the 6 chemical properties we expect our students to know when it comes to the chemistry of chlorine. Number 1 is bleaching action. Number 2, reaction with water, reaction with metals, reaction with non-metals, shall see what they are, reaction with alkalis, especially sodium hydroxide and potassium hydroxide, and its reaction with hydrocarbons. I hope you do remember the definition of a hydrocarbon. We shall see at the right time, at that moment. So I want to pick out one reaction, which is a reaction with water that the teacher had started on, so that we conclude on this reaction, then proceed to other reactions. So let us begin to discuss the chemistry of chlorine and water. So let's look at the chemistry of chlorine and water. Number 1, reaction with water. The information you need to pick is chlorine is readily soluble in water. So readily dissolves and reacts to form what we call a mixture. To form a mixture. This mixture is called chlorine water. Chlorine water. I am saying it is a mixture because we shall see that there are 2 compounds that will be formed when chlorine dissolves in water. And we shall see of what importance is this reaction when chlorine dissolves in water. So what is chlorine water? Chlorine water is a mixture of 2 compounds. Number 1, a mixture of a certain compound called hydrochloric acid, and the second one is called hypochlorous acid. A combination of these 2 compounds gives us what we call chlorine water. And this mixture, when looked at in terms of physical appearance, this mixture appears to be pale yellow. It has a urine smell, not urine smell, but a urine color, pale yellow. So the moment you pass chlorine through water, what happens? Water turns from colorless to pale yellow because of formation of hydrochloric acid and hypochlorous acid. In chemistry, information is summarized in terms of what we call equations. And therefore, this is giving us what we call a word equation. Water plus chlorine, we are getting hydrochloric acid and hypochlorous acid. What's the chemical equation out of this? And therefore, we shall see how this pale yellow solution affects the chemistry of so many things. So I want to summarize all the words that were written on a whiteboard into something small. Here we are. Chlorine is a gas. Let us not connect one another. Capital C, small l. Physical state, it is a gas. We are saying you bubble it, pass it through water, and the water at room temperature is a liquid. This reaction on taking place, we are obtaining hydrochloric acid. From your senior 2 chemistry, hydrochloric acid made up of hydrogen and chlorine. Hydrogen has a valence of 1, chlorine has a valence of 1. When we interchange, it remains 1 and 1, and when we lower, we remain with 1 and 1, and therefore this is the formula for hydrochloric acid. The interchange is done outside somewhere as rough work. So physical state of hydrochloric acid is aqueous. Definition of an acid: a substance which, when dissolved in water, produces hydrogen ions, which means it's aqueous in water. The second compound given here is what you call hypochlorous acid. Hypochlorous acid, the word acid means also in solution. So that is aqueous. So this is hydrochloric what? Acid. This one is hypochlorous acid. And this mixture appears to be pale yellow in color. The color of urine. Pale yellow. So this is what we are calling chlorine water. So this is a chemical property shown by chlorine. But before we drop this chemical property shown by chlorine, there are so many things we can talk about when it comes to chlorine water. So I want us to note the following. When you look at this equation, in terms of atoms, the atoms are balancing. These are two chlorine atoms. Here we have one chlorine atom, and we have another chlorine atom here. So 1 plus 1 is going to give us 2 in terms of atomicity. So here, chlorines are 2. This way it is 1 chlorine plus 1 chlorine. They are also 2. So chlorines are balancing. Let us look at hydrogens. We have 2 hydrogens here. Hydrogens are 2. H2, there are 2 of them. This way we have this hydrogen and we have this hydrogen. Hydrogens are also 2. What about oxygen? There is 1 oxygen here and there is also 1 oxygen here. So oxygen is 1 this side and oxygen on this side is also 1. So that equation in chemistry we say the equation has been balanced because the atoms on the left hand side are equal to the total number of atoms on the right hand side. So what is your summary? Your summary is chlorine readily dissolves and reacts with water to form chlorine water. Chlorine water is a mixture of hydrochloric acid and hypochlorous acid. Our questions are: what do you observe? What do you see when you bubble chlorine through water? What happens? Water is colorless. Now this mixture is pale yellow. So what is your observation? The colorless liquid turns to pale yellow. Why does it turn to pale yellow? Because of formation of a mixture of hydrochloric acid and hypochlorous acid, commonly referred to as chlorine water. So where do we find this chlorine water more applicable? Where do you use it? In so many things. Number 1, I said bleaching action of chlorine. The bleaching action of chlorine comes as a result of formation of chlorine water. Actually, the active bleaching agent is HOCl, hypochlorous acid. Hypochlorous acid, what gives chlorine water the pale yellow color? It is actually this one, which is pale yellow. So what happens to this pale yellow solution of hypochlorous acid and bleaching action? Because I remember in the physical properties, you were told by Mr. Margaret, chlorine is a bleaching agent. What is to bleach? To bleach means to remove color until a substance, something turns to white. So a blue cloth turns to white. A red cloth turns to white. A stained black turns to white. We say it has been bleached. So hypochlorous acid is a bleaching agent. Because what happens? Hypochlorous acid plus a dye. This dye can be color in your cloth. This dye can be a stain on your cloth. So the moment you soak a cloth that has a dye on it, a flower that is colored, anything colored, you soak it in chlorine water, what happens? This compound is very reactive. We say the dye picks oxygen from the hypochlorous acid. And therefore, what do you end up with? You are going to end up with hydrochloric acid, which is aqueous, plus this dye having picked the oxygen. So a dye here has a specific color: red, blue, black, green, yellow, and so on. While this dye, because of this oxygen, has lost the color, it turns to colorless. It is white. In most cases, turning colorless means turning from whichever color to white. So what has happened? Oxidation of the dye has taken place. So unoxidized dye has no color. A dye has a color if it is not oxidized. And chlorine, when it dissolves in water, forms hypochlorous acid that hands over this reactive oxygen to the dye. And in chemistry we say the dye has been oxidized. And what happens to hypochlorous acid? Hypochlorous acid turns to hydrochloric acid. And what happens to the pale yellow color? This pale yellow color turns to colorless because hydrochloric acid in the lab is a colorless solution. So observation. What happens to the dye? The dye turns what? Colorless. What happens to the pale yellow solution? The pale yellow solution also turns colorless. So this is a bleaching action. That's why we use jig in removing stains, because jig has almost the same behavior as hypochlorous acid, which is what jig is in the chemical reactions that are coming under chlorine. So this is one aspect. So what is one use of chlorine? One use of chlorine, it is used as a bleaching agent. How does it bleach? It dissolves in water to form hydrochloric acid and hypochlorous acid. It's the hypochlorous acid that bleaches. Alright, we shall see. Is it true that a dye comes out? Hypochlorous acid gives us oxygen. We shall find out. Where do we find this reaction being used? Application. Where do we find this reaction being used? Other than in the textile industry and so on. Where do we find this reaction being used? In normal life, at home. Some of the items we are using at home, substances we are using at home. Where do we find this reaction being used? In what? In water treatment. Wonderful. It is found in what? Use it in water treatment. What happens? Water that we use is contaminated with so many germs, with so many colors due to soil and so on. So what happens during water treatment? Chlorine is dissolved in water. And therefore the chlorine produces what? What did we agree? Chlorine plus water, what does it give us? Hydrochloric acid and hypochlorous acid. Hydrochloric acid kills the germs in water. So this one kills germs in water. What about this one? Hypochlorous acid bleaches water. What does it mean? It removes color in water and removes bad smell in water. Because water has so many contaminants. It has soil, the reagents being poured in and so on. When it rains, you normally see the color of water. It's brown due to mud. So how does it turn colorless? Hypochlorous acid is the one that bleaches all of the colored substances in water and removes bad smell. So practical application of this reaction. Water what? Treatment. And so on. That one has been registered. Second practical application, removal of colored substances in textile industries and in paper. Have you ever seen? This is a paper. This paper comes from wood. There is no plant stem you have ever cut and you see it as white as this. In most cases, when you check the stems of plants, they are normally brown and so on. So how does it turn to white? Bleaching action of chlorine. So those are two important applications of chlorine in the environment. Bleaching in textiles and in paper industry and water treatment. I want us to prove that, honestly speaking, hypochlorous acid has oxidant hands over. You get a test tube and fill it with chlorine water. What is chlorine water? Hydrochloric acid and hypochlorous acid. And therefore, what is the color of this mixture? We agree the color of this mixture is pale yellow. So what happens is that this is a test tube filled with the chlorine water and it's inverted and exposed to sunlight. Exposed to sunlight. So this is chlorine water, which has got, this is chlorine water, and we say it has what? Hydrochloric acid and hypochlorous acid. Now when you expose, and what's the color here? The color is pale yellow. So what happens when you expose this to sunlight? Hydrochloric acid is stable. It is just stable, it doesn't decompose. It is this compound which is unstable. So when you expose this to sunlight, what's going to happen? The hypochlorous acid, which is unstable, in chemistry we say decomposes. To decompose means to change, to undergo a chemical reaction to produce something that is new. So hydrochlorous acid decomposes to hydrochloric acid and gives out what? Oxygen as a gas. So what will you see if you observe this experiment, put under sunshine for some time? What will be important to see? Our observations, what can be seen? So what can you see? Comment about the color. The color of the mixture is pale yellow. Now it is turning to hydrochloric acid. What's the color of hydrochloric acid? Colorless. So what happens to the pale yellow solution? Turns to colorless. What else do you see? You can't see oxygen as a gas, but you see bubbles. So there are two things. Number one, pale yellow solution turning to colorless. And number two, effervescence, or we see bubbles of a colorless gas. Which colorless gas must be? No gas other than oxygen. And therefore you must support this reaction with an equation. So it is only HOCl, hypochlorous acid aqueous, that undergoes a chemical reaction in sunlight. And therefore what have we said? What does it produce? It produces hydrochloric what? Acid. And what is given out? Oxygen. Or we could have left this equation like this. But remember, oxygen atom is unstable. It needs two atoms to come together to gain the stability. So we can't leave this equation like this. At room temperature, what's the formula for oxygen? The formula for oxygen is O2. This is the chemical, O is a chemical symbol. But the formula for oxygen is O2. Hydrochloric acid is aqueous. Oxygen is a gas. We agreed that this one is pale what? Yellow. Now this one is colorless. And this is seen as a gas bubbles. Gas bubbles. Gives us what we call in chemistry an observation. So if I'm to ask a question about this, I expect 3 marking points. Pale yellow, colorless, bubbles of a colorless what? Bubbles of a colorless gas. Now, let us look at this equation. Is the equation balanced? Maybe no. There is one hydrogen. There is one hydrogen. That is okay. There is one chlorine. There is one chlorine. That is fine. But here there is one oxygen and there are 2 oxygens. So what do? We have to make the number of oxygens equal. Here it is 1, the other side there are 2. So what do? A number which is 1 here has not what? Helped us. Because there is a number here which is 1, not written, but it's there 1. It has not helped us. So we try the next number. In balance, the equation the cheapest is try to make numbers that are odd, yet they are even on one side, make them even. So oxygen is odd here, oxygen is even this way. So let's make oxygen this side also what? Even. Here it is odd, there it is even. So we must do something. We convert the odd one to an even number. Here it is odd, and here it is odd. Here it is odd, this is odd also, okay. So we are looking at here being odd and here being even. We make odd even, we make all of them what? Even. So, which number can we multiply by the odd number? Here 1 and we get an even number which is 2 there. It becomes what? A 2. So when we do so, what happens? Oxygen becomes even, but now hydrogen and chlorine have changed. Here they are now even, the other side they are odd. So also make them what? even. And the simplest even number is 2. It becomes a balanced equation for reaction. It is true that hypochlorous acid decomposes to give out oxygen. That's why paper, they die in your cloth. They die in paper. They die in water. The black ink stained on your cloth will capture this reactive oxygen to get oxidized and end up forming the color turning to colorless. So this is an important property. And if you can visit UNEB past paper bank books, you're going to get these questions available. For example, 2 years from now, there was a question on chlorine water. Last year, there was some question on chlorine water and they die. And they say, what would happen if a piece of handkerchief which has been stained with black ink is put in a gas jar containing chlorine? So what will be the answer? It's bleached. It turns to colorless. Explain. Chlorine dissolves not to form hypochlorous acid and chlorine. Hypochlorous acid and hydrochloric acid. Hypochlorous acid oxidizes, they die. And the color turns from black to colorless. Because we're talking about specifically black what? Black ink on a handkerchief. So this is one of the important chemical reactions that are shown by chlorine. So if there are any issues, you raise them through messages and we shall be in position to respond to them. So allow us at this moment to push on to the next property. So here I have looked at 2 things. Number 1, the bleaching action, and number 2, the dissolution of chlorine in water. So we are ending by saying chlorine is a bleaching agent. Number 2, chlorine readily dissolves in water to form hydrochloric acid and hypochlorous acid. That mixture is called chlorine water. Chlorine water is pale yellow. When exposed to sunlight, the pale yellow color turns to colorless because of decomposition of hypochlorous acid to form hydrochloric acid, and oxygen is given out, seen as bubbles of a colorless gas. It is this oxygen that causes the bleaching. 2 applications of this reaction. Number 1, treatment of water. Hydrochloric acid kills germs. Hypochlorous acid bleaches and removes bad smell in water. Number 2, removal of colors in textile industry and in paper industry. Full stop. So let's look at property number 2, which is also the same as almost property number 3 because we have 2 things in one. Let us look at reaction of chlorine with alkalis. Reaction of chlorine with alkalis. I expect my students to know what an alkali is. What is an alkali? A substance which when dissolved in water produces hydroxide ions as the only negatively charged ions. So give me examples of alkalis. 2 common examples of alkalis. The 2 common examples of alkalis include sodium hydroxide and potassium hydroxide. There will also be another one later which is ammonium hydroxide. But I'm saying common ones. Those are the 2. So we are seeing, can chlorine react with those 2? Is it possible? Is it possible? Yes or no? Is it possible? It's yes. Why yes? It is possible because this is a base. Chlorine is an acidic what? Gas. So I expect a reaction. I want to remind that chlorine is acidic. It gave us hydrochloric acid and hypochlorous acid in water. It is true that sodium hydroxide or potassium hydroxide are basic. So what do you expect? Automatically we expect a reaction to take place. What are we going to form? Acid plus a base, what do we form? We form a something that is something that may be related to or called what? A salt. That is it. So it is not possible in biology. This is a male-female organism, and this is a male organism. It is not possible that you can bring the two together and you don't expect a chemical reaction. Because one is the opposite of the other. There must be a chemical reaction. Whatever products that are going to be formed, we shall leave it, but for us the product to be formed in this reaction is a salt. So at times you must know why certain things react and others not what? Do not react. So I'm expecting a reaction. I'm expecting a salt. So there are two things that the syllabus requires you to know when it comes to a chemical reaction between chlorine and alkalis. There are two conditions. Number one, when the alkali is dilute and cold, that is at room temperature. So what am I saying? A reaction between chlorine and dilute sodium hydroxide at room temperature. For example, then you will help me, and I'm not underestimating anybody. My conscience tells my students can tell me the product. If I mention one, they can tell me the product in the other. Especially these two. Leaving that one out, shall come to it later. So what's going to happen here? One being acidic and the other being alkaline, a reaction will take place to give us a salt. What will be the name of the salt? We shall get two salts being formed. Number one, if I'm to use sodium hydroxide, I expect the salt to be sodium chloride. Being dilute, it must be a what? A solution. That's one of them. The second product is a relative of chlorine water, hypochlorous acid. This time is called sodium hypochlorite. And the last product of the reaction is water. And these are common questions in paper 1. These are common questions in paper 1 objectives. So what's the formula for sodium chloride? Somebody should be patient telling that sodium has a valence of 1, chlorine has a valence of 1. When we interchange and lower, it remains capital N, A, C, L. Non-designed symbols. We have seen the solution, it must be aqueous, physical state. Sodium hypochlorite is a relative of chlorine water, hypochlorous acid. So what shall we do? We shall delete hydrogen and put there what? Na. So the formula of sodium hypochlorite is NaOCl. And therefore, quickly, for those who have seen the first property, must be seeing, you must be seeing some bleaching properties again coming again because of the same oxygen. What's the formula for water? The formula for water is H2O. Now we can come up with a chemical equation because we have a word equation. So if we write notes, the notes are available on the website. But if we write a few things, statements, it means chlorine being acidic readily reacts with alkalis to form respective salts. And what are these salts? It is to form a salt, a hypochlorite, and water. A chloride, hypochlorite, and water. The name of the chloride depends on the name of the base. If I'm using, for example, if I'm using non-fuma hydroxide, what do I expect? I must be getting non-fuma what? Chloride. And non-fuma hypochlorite. So the name of the chloride and the chloride depends on the type of alkali that has been used. So what will be the name of the chloride if I use potassium hydroxide? Potassium chloride and potassium hypochlorite and water. Our equation, ladies and gentlemen. So let's look at the equation. That's the word equation now. Senior 1, senior 2, senior 3, write chemical and balance. So what's the formula for sodium hydroxide? NaOH. Non-factor N. Don't design N. I must see two sharp points, this point and that point. I want to see this type of N. This one I refer to as a facultated N. You have seen extended. We don't want design symbols. Don't bring faculty symbols here, especially N and N. So what's the physical state? We agree it is what? Aqueous. Plus chlorine, the symbol is Cl2 and it is a gas. What does it give us? We have already seen the sodium chloride. So sodium chloride is NaCl and it is aqueous. What else is given? Sodium hypochlorite, which is NaOCl. It is also aqueous. What else has been given out? Water. That is a liquid. The letters are not connected and they are not bad symbols. So that is it. So what's the name of this one? Sodium chloride, sodium hypochlorite and water. I know alone wherever you are, you can write the equation between the potassium hydroxide. You can write the equation. Before we think of balancing, so I am giving you about 30 seconds, wherever you are, to write the equation and balance equation between the potassium hydroxide and chlorine and name the products being formed. 1 minute now. Write the equation and balance shall balance and go back and balance. Write the unbalanced equation of reaction between dilute potassium hydroxide solution and chlorine. Full stop. Name the products formed. Name the products formed. By this time, you should have finished right. So I'm expecting the following from all of us. For me, I'm lucky that for me I can easily delete, erase, and insert. So I'm coming. The name of one of the products should have been potassium chloride. Spelling must be correct, double S. And the formula for potassium chloride is KCl. Therefore, this one should have been also potassium hypochlorite. And therefore, I'm deleting Na and I'm putting KOCl. That one remains as water. So what is my equation, the chemical equation here? The chemical equation is potassium hydroxide, that is aqueous, plus chlorine, that is a gas, is giving us potassium chloride, that is aqueous, plus potassium hypochlorite, that is aqueous, plus water, that is a liquid. If your equation looks like that, for the time being, you pat on yourself like a lizard, but there is a problem, the equation is not balanced. So wait until you balance the equation. Let us go into atomicity and we see. Let us go into atomicity and we see. Allow me to remove this second equation. Or let us use the second equation. It will help us look at the first one. Let us look at potassiums. How many potassiums are present on this side? Only one. How many potassiums are present on the other side? There are two. So K's are 2. What does it tell you? The equation is not what? Balanced. Already. Let us look at oxygens. How many oxygens are present this way? One oxygen. How many oxygens are present the other side? 2. This one and that one. So those are 2. Let's check on chlorine. A. Hydrogens. How many hydrogens are present this way? 1. H is only 1. How many H's are the other side? H's are 2. Chlorines. How many chlorines are this way? 2. How many chlorines are this way? 2. What did we agree? In the balanced Ionic equation, make the numbers that are odd to become even if there is frequency between odd and even. This is even versus even. We have nothing to do with it. It's not to give us the guiding principle. Now this is odd, the other one is even. Odd, even, odd, even. So let's convert these odd numbers to simplest even numbers first. So what's the simplest even number? Is a 2 by multiplying by 2, which means we shall put a 2 here. When we do so, what happens? Potassium also becomes what? 2. This one also changes and becomes a 2, and a 2 becomes a balanced equation for the reaction. So what is this here? This is now a 2. It becomes a balanced equation for the reaction. This chemical name, what is the chemical name of this compound? What did we say? Sodium hypochlorite. What about this one? Potassium hypochlorite. The commercial name. When I talk about the commercial name, what do I mean? The name on the market, outside the chemistry class. This is your so-called jig. And what's the use of jig? Bleaching. Why? Reactive what? Oxygen. And what happens when it bleaches? It turns to sodium chloride and turns to potassium chloride as it gives out oxygen. The equation is similar to that of HOCl. So even if you want, you can now write that equation 2. Give us HCl plus O2. So here what is going to happen? 2 moles of NaOH will give us 2 moles of sodium hydroxide. Oh, sorry. Yes. This is OCl. Sorry. 2 moles of sodium what? Chloride plus 1 mole of what? Oxygen. So this is also a bleaching agent. Jig. Commercially referred to as. So jig is in this family. Don't we use jig as human beings to change our colors? We do. Mbushi has bleached. What do they use? Anything that has OCl in it bleaches. Whether it is a smearing oil, whether it's a liquid you are showering, so that today you are darker skinned, tomorrow you are light skinned in specific places, other places remain dark, you become Merina Pip's color. It's because of the OCl. So what bleaches is the OCl, irrespective of what is here. So as long as you're OCl, you bleach. Are we there? Yes. Yeah. So what describes a male? It doesn't, it's not your name. They are males. You know what qualifies them to be males. So they are bleaching agents. What qualifies them to be bleaching agents? At least a very bit of OCl, the hypo. So this is when the solution is cold and dilute. What happens when the solution is concentrated and hot? So concentrated and hot. Concentrated and hot alkali. The products are different. The products this time are different. We shall still get a chloride, this time we shall not get a hypochlorite. This time we shall get a chlorate. And we shall also get what? Water. So what's the formula of the chloride? I am putting dash Cl here. I am putting dash ClO. This time it is what? 3. By then the other you can also write it as, you can write it as HClO. You can write it as NaClO, the hypochlorite with 1 oxygen. Then it gets a 3, it becomes an 8. From an 8 to an 8. So chlorate with 3 oxygens. So water remains H2O. So if I'm to use sodium hydroxide, concentrated, hot, what will be here? Na. So that becomes sodium chloride and it becomes sodium chlorate. It remains water. If I'm to use KOH, it becomes potassium chloride and potassium chlorate and water. Therefore, these are challenging questions which must be passed by students in objective papers. And once you have come across them, you can look at the answers and easily remember and pick the correct alternative. So let us again think of the chemical equation and see. Let's use sodium hydroxide again. So sodium hydroxide, this time written like that, and is aqueous, plus chlorine again. What does it give us? Sodium chloride, aqueous. NaCl, aqueous, plus, we talked about sodium chlorate. And the sodium chlorate is NaClO3. It is also aqueous. Plus, what else has been formed? Water as a liquid. In our usual style, we now get interested in finding out whether the equation is balanced or not. Let us try out and see, is the equation balanced or not? So, here what do we notice? Sodium is only 1. Here sodiums are how many? 2. There are 2. There is a problem already. Oxygens this way is 1. Oxygen the other side are how many? 4. Oxygens are 4. There is a big problem now. Now let us check. Chlorines, there are 2. And chlorines this one are 2. So Cls are 2. And here the Cls are also how many? 2. Hydrogens. Hydrogen this way is 1 and hydrogen this way is 2. So who is going to determine which factor do we use? Do we use a 2? Do we use a 4? Because of oxygens, this one there are 4 the other side. We can't use it because when you use a 2, they will become 2, they will become, but they will remain 4. Which means probably shall try the one. Maybe try now. Simplest number we can try now is what? Is a 4. The simplest, as for now, we can try, maybe it is a 4. And when you use a 4, it means oxygen works out. So if you use a 4, oxygen works out. So oxygens are now 4 this way and they are now 4. So this is times what? 4. This is now times 4. This is now times 4. Isn't it? And this is now times 4. Is what we have done. So what do we obtain this way? This is now going to be how many? These are going to be how many what? 4. Are we there? No, they can't be 4. This time how many are these ones? 2. They are only 2 this way. Here they are 4, the other side they are 2. Here oxygens are 4. Now here oxygens are 4. So it means that this one is now okay. How many chlorines are this way? Only 2. The chlorines are 2. That one works out. Hydrogens are 4. Here hydrogens are 2. Have you seen these are 4 hydrogens? But here how many hydrogens are available? 2 only. So this one works out. That one has worked out. Now the problem is here. Here there remain 2 only. But here there are 4. So what do we do? we need to change this one to 4. And by changing this one to 4, the only place where hydrogen is there. And therefore, when I plant a 2 here, what has happened to oxygens? They begin to change their position. Now these are 4. Maybe if they are 4, maybe if they are 4. The moment I tamper with this one has many atoms, it's going to create a bigger problem. Maybe I try this one. If I put a 3 here, what has happened to chlorines? Sodiums are now also 4. Chlorine has switched themselves to how many? 3 plus 1, they are 4. So these are 4. But there is a crisis that oxygen has changed its position. These are how many oxygens now? A total of 5 of them versus 4 this way. Because of hydrogen, it is not possible that we can use a 5. So a 4 has not helped us as the least. We try the next least number is a 6. And if it's a 6, what happened to the number of hydrogens? They are 6. And therefore, what do we do? A 3 there. Now let us check how many oxygens are those that are available. Oxygens are what? 6. So we are not tamper with oxygen, we shall play about with the others. Hydrogens and oxygens are working out. So what can we tamper with? We have a total of 6 sodiums. Here there are a total of 4. But we are not going to tamper with this one because of the oxygens and the hydrogen. We cannot manipulate this one now. Isn't it? So if this is 1, how many more do I need to raise the number to 6? 5. So I can try a 5 here. And indeed when I put a 5 there, what happens to the oxygens? They remain okay. Sodiums are now okay. Hydrogens are okay. Our biggest challenge is now chlorine. How many chlorines are these? 5 plus 1, 6. These are how many? 3. So there is 6 versus 3. What does it call for? A 3 there. It becomes a balanced equation. So what's the difference between these two reactions? One requires cold, room temperature. The other one requires hot, concentrated. And the product is one forms a chloride, another one forms a chlorate. For your own information, wherever there is oxygen, high oxygen content in the compound, bleaching effect. Therefore, this one belongs to the Vim families. So if I remove Na and put Ca, it becomes calcium what? Chlorate, and this is Vim. This is Vim. It also has bleaching abilities and so on. So that is it. And therefore, you must capture the difference between dilute, cold, and hot, concentrated. Especially paper 2 and paper 1. I want to guarantee when you check the question bank book, these questions are there. So, I think the one for potassium now follows suit. So what's the one for potassium? 6 moles of potassium what? Hydroxide plus 3 moles of chlorine. What we obtain? 5 moles of potassium chloride plus 1 mole of potassium hypo of potassium what? Chlorate plus 3 moles of water. And as students, you can even come up with what we call ionic equations. We can come up with an ionic equation in both situations, because there are cases where the paper demands that you write an ionic what? Equation. So sodium hydroxide, what does it give? It will give us sodium ions, and it gives us hydroxide ions. Chlorine will give us chlorine, 3 moles of chlorine as a gas. How many moles of sodium ions are these? 6. Hydroxide ions are also what? 6. Plus 3 chlorines. What do we get? 5 moles of sodium chloride. So sodium chloride solution will give us 5 moles of sodium ions plus 5 moles of chloride what? Ions plus. The chlorate gives the same. The chlorate will give 1 mole of a sodium ion plus 1 mole of a chlorate ion, written like that. Yes? Plus 3 moles of water. So what do you know about ionic equations? Whatever is formed this way and that way, do what? We remove. You know, I taught this way, you remove them. So 6 sodiums here. Do you see 5 here? So if I remove this 5, I'll remain with 1, isn't it? And again see another one here, so I remove those ones. So what remains? An ionic equation. So what is our ionic equation? 6 moles of hydroxide ions plus 3 moles of chlorine as a gas. This is aqueous. What does it give us? 5 moles of chloride ions, aqueous, plus 1 mole of a chlorate ion, aqueous, plus 3 moles of water. There are cases where the question demands an ionic equation. So I want you to use today's discussion to write the ionic equation between sodium hydroxide and dilute. So assignment, you write an ionic equation for reaction between Roman 1 chlorine and dilute, between chlorine, Roman 1 between chlorine and dilute sodium hydroxide solution, Roman 2 between chlorine and concentrated potassium hydroxide solution. So in our next discussion, we shall be looking at reaction with nonmetals, with ammonia, with metals, and I want to encourage that the notes have been already uploaded on the website. Please go to the website, download the notes, read, so that we move relatively what? Faster. Otherwise, it is possible that if you have done prior reading, you can follow the discussions very well. So those who have issues with questions, you'll be in position to send. Somebody is saying, is it hypochlorous or hydrochlorous? It is called hypochlorous acid, not hydrochlorous acid. HOCl is hypochlorous acid, and NaOCl is sodium hypochlorite. It's not hydrochlorous acid. So I want to thank you so much for attendance. Take care. COVID is real. We have lost very many people. Please don't move out of your homes. And in case you are to do so, don't forget a mask. SOPs, wash your hands. Assalamu alaikum wa rahmatullahi wa barakatuh. So you go on the website, notes are there. You can download the notes so that next time you move faster. Assalamu alaikum.